This is Chapter 2, Part 6, and we're going to be talking about bonding, and we're going to start out with covalent bonds. So you remember that chemical bonds are the union between atoms, and it is really the electron structure that's interacting when the two atoms are interacting. And so when two or more atoms are joining together, it's a molecule. If they are different elements that are bonding together, then we call it a compound molecule. So for instance, H2O, or water, that's a compound molecule, where if you just had two hydrogens interacting, that would just be a molecule. So when you're thinking about bonding, think electron structure, and it's really going to be the valence electrons that are going to be really important. So remember that in the first shell, you can have how many electrons? Hopefully everybody's screaming out 2 electrons. In the second shell, you can have how many electrons? Again, hopefully everybody's sitting there saying 8 electrons. In the third shell, you can also have 8 electrons. We don't worry too much past that because those are not elements that are that important for biological molecules. So when you think of one of the most important kind of bonds is a covalent bond. It's a very strong bond. And in a covalent bond, atoms are sharing electrons. This is really important to be thinking. The sharing of electrons is the really important element here. 2 atoms are sharing electrons. So we'll talk about that. And you can have a single covalent bond in which they share 1 pair or 2 electrons. A double covalent bond where they share 2 pairs or 4 electrons, and a triple covalent bond where they share 3 pairs, so 6 electrons. So single, double, triple. So hydrogen atoms, when 2 hydrogen atoms come together, we are going to have, if you remember from the periodic table, for hydrogen, there's a 1 on top and a 1 on the bottom. So how many protons? There's 1 proton. And in an uncharged atom, we're going to have 1 proton and we're going to have 1 electron. So that's a hydrogen atom. In that first shell, it would like to have 2 electrons. So it can meet up with another hydrogen atom, which would have another with its own electron. So let's try where we have 1 hydrogen with an electron, and it is going to share with another hydrogen. When that comes together, they can share that pair, and so we will have a horrible drawing, but you can get the idea. 1 pair of electrons are being shared. And we'd write that as a single covalent bond. Covalent bonds have a solid line. So let's listen to this little.
A covalent bond is the sharing of a pair of outer shell electrons by 2 atoms. For example, each of these hydrogen atoms has 1 electron in its outer shell, but needs 2 electrons to complete its outer shell. If the 2 hydrogen atoms share electrons, they can both complete their outer shell. The shared pair of electrons constitutes a covalent bond, shown in shorthand as a line. The covalently bonded hydrogen atoms form a molecule of hydrogen gas. A molecule is defined as 2 or more atoms held together by covalent bonds. An oxygen atom needs 2 electrons to complete its outer shell. 2 oxygen atoms can share 2 pairs of electrons. A molecule of oxygen gas is held together by a double covalent bond, 2 shared pairs of electrons. A carbon atom needs 4 electrons to complete its outer shell. It can share electrons with 4 hydrogen atoms, forming a methane molecule containing 4 single covalent bonds. Methane is a compound, a substance formed by the combination of 2 or more elements. We call methane natural gas. It is the fuel burned in gas stoves and furnaces. An oxygen atom needs 2 additional electrons to fill its outer shell. Thus it can form 2 single covalent bonds. An oxygen atom can share electrons with 2 hydrogen atoms, forming a molecule of water containing 2 single covalent bonds.
Okay, so as they said, hydrogen can come together and form one single covalent bond by sharing one pair of electrons. Oxygen, you can have a double bond where 2 different oxygen atoms come together and share 2 pairs or 4 electrons. Water, where this would be a compound molecule, where oxygen can form a bond with hydrogen and form another bond with another hydrogen, each single covalent bonds. Methane, where you have 1 carbon sharing 4 different electrons with 4 different hydrogen atoms, so each carbon-hydrogen bond is sharing a pair. So in the next segment, we're going to look at how many covalent bonds each atom can form.